Hey everyone, how's it going? Good. Welcome to PNW Scala. My name is Evan. So we've had 2 talks on, Paul had an excellent talk on Scala, what's wrong with it? And we have a talk on JavaScript. We're going to change tax a little bit. I'm going to be talking about Akka today. I'm a staff engineer at Uyala. Namely, if you've watched any video on ESPN.com, Victoria's Secret, REI, you've probably used our software without knowing it. We process all of the video that consumers watch from a lot of sites. And my Twitter credentials and GitHub account if anyone's interested. And that'll be it for me. So, do you want reactive programming? How many people have heard of the term reactive programming? Yeah, it's starting to get around. There's a really cool site called the Reactive Manifesto that talks about the new way to build applications. Is it about reactions blowing things up? Well, no, not really. But it's about building event-driven, scalable, resilient, and responsive apps. Today, it's no longer enough to do the standard, the old Java model with a thread per user, processing stuff. We need something more. And so a lot of you guys might be looking at Akka. How many people here have heard of Akka? Okay, good. And how many people have used Akka and have Akka systems in production? Nice, nice. So this talk will be useful for a lot of you. Maybe some of you are thinking of using Play. Play has gotten a lot of press. Play is built almost entirely in Akka, right? So what we'll talk about is how we use Akka at Uyala and our experience with using it in production and some tips and tricks. And we'll also show some Scala code examples as well. Who we are. So Uyala was founded about 6 years ago by Google engineers. Since the very beginning, we have put a pretty big emphasis on analytics, realizing that it's really important for video publishers to understand, where the content's coming from, and so we do a huge amount of volume. Like every time someone watches a video, the events stream to our servers constantly. We get over 2 billion. I mean, this slide is actually old. I think we're over 2.5 billion events a day. How do we start using Scala? So we were actually mostly a Ruby company, plus a little bit of JavaScript, ActionScript, C++ here and there, even MapReduce jobs. Now that was pretty interesting. And our experience with what we learned out of that was that Ruby is not really a good fit for big data. It is slow. It is very slow, actually. It has no type safety. Now the type safety thing, Ruby is good for a lot of things. But the problem with using it for big data, and especially for Hadoop, is how many people have tried to unit test, or rather functional test, Hadoop MR jobs? I only see a few hands. It's not very easy. And especially if you have a language that is not type safe, it becomes really, really hard. If you can't test 100% of your code in Ruby, then you're in trouble. And this is especially true for MR, where you have long cycles. Ruby works well when you have really small iterative loops, right? You can run stuff again and again really, really fast and correct mistakes. And for MR, that is not true. We started exploring Scala for real-time analytics and for and MR jobs. And what we found was that using Scala gave us an order or 2 orders of magnitude improvement over Ruby. Pretty awesome. So today we use Scala and Akka for basically all of our big data pipelines with Storm, Spark, Cassandra. How many people here have heard of Spark? Cool. I won't talk about Spark, but if you're interested in talking about Spark with me, I'm also a contributor to Spark. Now one of our core problems is that when you build a big data pipeline, the first thing is that you have to ingest events. So let's say a user is playing video. That goes into something like Nginx server, and then we process it a little bit, push it to Kafka, and then we have more processing steps afterwards. So this slide is just to give you some context to the other whole bunch of slides coming up about how we use it. So the first Scala app that we built, we call it Livelogsd. that takes logs from Nginx and tails it and writes it to Kafka. So you can imagine that Nginx writes out a log file, that's a current file. Then what it does, it rotates it every, I don't know, minute, 5 minutes, whatever, right? And what we did was we have an actor that is tailing each file. And as it rotates it, it keeps tailing it. And what that allows us to do is that, if we fall behind a little bit, then we can essentially tail like multiple files. If we fall behind, we can, once a new file gets created, we can tail it right away, and we can feed these events. It was a very, very simple, kind of like test app. It was with Akka 1.3 or something like that. It was like early days. So that's it. Next, we decided to do a real-time analytics product. And at that time, Storm had just come out. So everyone was very excited about it. We started to try to use it. Now, you might ask the question, what does Akka have to do with Storm? It turns out not that much. I mean, you don't have to use Akka in Storm. But in Storm, you have what are called bolts. And bolts are individual processing units. And they can be scheduled anywhere. You just tell Storm what it does, and it figures out where to go and how to tie them together. Here's the problem, though, is that bolts can live on different nodes, and they might die or get restarted independently. And for part of the pipeline, we didn't actually want that. We wanted a whole bunch of components that were concurrent to start up together. So we decided to use several Akka actors within a bolt that talk to each other. So kind of just an interesting use of Akka. Now, what occurred to me, though, that one of the interesting things that occurred to me about Akka was that Storm could have been actually built with Akka, but it's not. What do we find about using Storm is that in production, Storm is difficult to troubleshoot. We had a lot of nights at 2 a.m. where we figured out what the heck is going on. At 2 a.m., you don't really have patience to figure out what stuff is going wrong. You see that on every node, Storm has a supervisor in process. Then it spins up several worker processes. In addition to that, it has a single master called Nimbus. And then there's Zookeeper. And you're not really sure what is going wrong, so you start restarting services. You restart Zookeeper, which you shouldn't do. You restart Nimbus. You restart the supervisor. You're trying to figure out, why is the performance not up to par? There's a lot of moving parts, and there's a lot of log files also. It's not easy to separate out, just figuring out, did something happen or not, looking in several log files. It's not easy. Right. So instead, we started to, for our new ingestion pipeline, we decided to move away from Storm and to use Akka entirely. Now, this diagram shows we were trying out Akka Cluster. If you haven't heard of Akka Cluster, it's really neat. It's an Amazon DynamoDB style system where it's peer-to-peer. So you spin up a couple nodes, they gossip and they talk to each other. If new nodes come up, they know that they exist. So this is really cool. We tried it out when it came out in experimental mode in 2.1. And what happens is that we thought, okay, we want to build an HTTP ingestion service because that way multiple users can talk to it. The one team can own the HTTP service, which is really nice from a separation standpoint for team-wise. So what we do is we have spray endpoints and HTTP endpoints. Then you talk to a cluster router. Now the cluster routers will know which node to spread messages to. The reason is because we have processing that happens, and there's some state in it. So we want to reroute messages to the correct node based on a consistent hash. And you can do this in Akka cluster. So this was fine. We got it up and running onto a production cluster. However, this was still too complex. The question again became, do we want to get page for the system? There's, again, multiple nodes talking to each other. And we found that in 2.1 at least, our cluster wasn't ready for production yet. There were still nodes be going down and we wouldn't be able to bring them up. I think that the new version is actually pretty stable now. It's no longer experimental. It's at 2.2.1 now. So I don't let this dissuade you from using it. I was just saying that at that point, it was not ready. Oops, sorry, let me go back a bit. And the other thing is that doing HTTP in Scala often means dealing with futures. Futures are really nice because I don't know if you if you're not aware of a feature, basically, a feature lets you say, I want to do some work asynchronously and then get back a result later. And this is perfect for HTTP because HTTP is request response. I want to send some work out and do it later. Now, in order for this to work with Akka, you mix it in with actors. So in the future, from HTTP, you might send it to some actor and for it to do some work. And there might be a chain of futures. But what we found was that mixing futures and actors is also a bit complex. And the other thing is that from a development standpoint, we have a lot of developers that are, we're very few people that are seasoned in Scala, and explaining futures is actually not easy. I've had multiple times when I've had to explain what futures were, when things happen. And just conceptually, it's kind of difficult for people to grok. Whereas we never had any problems explaining actors to people. People just seem to get actors like very easily, maybe because they map very well to an object-oriented framework. So that's just something that we found. So finally, we evolved our pipeline to be a really simple design. What we do is we use Kafka to partition messages. Based on a certain key, you can send messages to different Kafka partitions. And one of the first rules that you've heard about distributed systems is don't distribute. So in this system, there's no distribution other than spreading messages across partitions in Kafka. You have independent Akka processes. They just read from Kafka and write to Cassandra. There's a pipeline of actors. There's first actor reads from Kafka, second one does some conversion, the third one writes it. It's actually a little bit more complex than that, but it's still a linear system. It's all actors, and it's very easy to understand. So we're finally at a point where we have a very easy system to deploy, very easy to debug. If anything goes wrong, it's just one process, one log file, and it's been running very well. So since this is a Scala talk, I'm going to switch a little bit to talk about stackable traits. Traits are one of the great features of Scala. You can put a little bit of functionality and mix different traits together. But it turns out that you can stack them also. And you can do some pretty cool stuff with it. Now, when you productionize code, you often start to add, your beautiful little functions start to look more and more complex, right? You add logging, you add metrics, and soon like over 50% of your code is like kind of production-y stuff. Has anyone seen that? That's right, everyone's seen that, right? So traits to the rescue, right? Here at the bottom, we see an actor class. You have some functionality in your receive block. If you're not familiar with actors, the receive block is where you handle messages. So let's say that I have something called wrap receive. That's where my real work is, and I want to do something before and after. But I want to do it in a way that doesn't clutter my code, right? So these are what stackable traits let you do. As an example, So let's say that I have a base trait. What this base trait does is, I call it actor stack. There's really just two components to it. One is called wrap receive, which is that I've moved the receive block of actor classes to a second, I just renamed it essentially to something called wrap receive. And then what happens is that the traits that modify the behavior of the receive block is going to sit in the regular receive, and you'll see how this works in a second. Receive blocks are what are called partial functions in Scala. That means that they can handle some messages and not do others. So when you say it's defined that tells you if the wrap receive block is going to handle a message. Otherwise, it goes to a built-in function in Akka actors called unhandled, which processes messages that are not that aren't processed. Now, let's say that I have two traits to instrument my actors. This is called instrument 1 and instrument 2. What they do is that they override the receive method, and you'll see something called super.receive. And what that does is that will pass, that will call the next trait on the stack back up to the original actor stack, which calls the wrap receive of the base actor. And so you notice instrument 1 does do something before, instrument 2 does antes. Now if you mix both of them together, let's say that I do extend actor with instrument 1 with instrument 2. Now you notice that the body of my function is very simple, and the order that you mix it then determines the order that the behavior modifiers get called. So if I go back a little bit, you notice that instrument 2 is the last one in the stack. That one gets called first. Then it calls instrument 1, which is the next superclass. Then it calls actor stack, which is the parents. And then that calls the dummy actor. So that's the order that happens. And we'll show some examples of how we use this. So productionizing Akka. Finally, we get to the meat of the talk. We have a standard stack of technologies. We use Spray. At that time, when we started using it, Spray was, it seemed like the best choice for actually integrating with Akka. Since then, other frameworks, web frameworks like Scala have Akka integration. You guys might have just seen the news that TypeSafe acquired Spray, so it looks like Spray will be here to stay as part of Akka, called Akka XGP. We use Logback, which I'll explain in a second why we use Logback. Yammer metrics, Spray JSON. And we package this all in a single jar so that it's very easy for new Akka apps to be deployed with like this entire stack. I'll be talking about visibility a lot. It's been said that the only thing that really matters in distributed systems is visibility when it comes to debugging. So the first level of visibility, which everyone has to have, is logging. So we like to use Logback with a custom logging trait. There is a built-in actor logging trait in Akka, but we don't use it. The reason is because actor logging does a logging level based on a static configuration. But we like the ability to have dynamically adjustable logging levels, and Logback gives you that. You can actually go into JMX and adjust your logging level, which is super useful in production without having to restart your services. So instead, what we do is that we have defined our own trait that lets you use Logback directly. One thing that actor logging gives you is that it will print out the path of your actor in your logging, which is pretty useful. So we have a way to put that back. Basically, in SLF4J, there's an interface called MDC. And all you need to do is do a put to some variable like actor path. And this would be easier if we just look at a trait. So this is a slightly simplified version of our trait. Again, this uses the actor stackable trait pattern. You'll notice that every actor class it mixes in gets a default logger val. And at the beginning, we immediately log that we're starting this actor. This is very useful for debugging. But the meat of it is that when we receive a message, the first thing we do is we do mdc.put, which allows me to have my actor path in the logging. Now, if you might be wondering why we need to do this for every invocation, the reason is because every time an actor receives a message and does processing, it could be on a different thread. So the MDC mechanism is tied to particular threads. So that's the reason why every time you get a receive, you need to reset the MDC. The next thing, after you do logging, logging is good for looking at exceptions, but when you need to look at performance, logging is really not good, right? So what you really need are application metrics. So we have a trait that adds 2 metrics for every actor that basically looks at how frequently are messages coming in to an actor and the time spent in the receive block. And what we do is that we expose these metrics through a common route, metric C, for all of our apps. Then we pull it and send it to a collection service. And the way that the trait works is pretty simple. Again, this is a stackable trait. We define a new timer for the actor. And if you're not familiar with the metrics library, what a meter does, it allows you to measure the duration of a block of code, as well as it gives you frequency. So all we do is we wrap the receive in a try finally, and we start the timer, and then when it exits, we stop it. This gives us very interesting graphs. This is a Datadog graph of a stacked graph of the different actor pipelines. different stages in the actor pipeline. And you can see the pink is one of the earlier stages, and the pink, the light pink is the earlier stage, and then the one on top, heavier pink, is the later stage. And you can see over time that the time that is spent in each actor class varies, and you can pinpoint that something might be happening with this light pink actor. And in fact, if we correlate to other metrics, that is true. If we correlate to the latency that's happening through the system, we can see that that point in time when there was a spike also happens to be when things are getting delayed. And so, yeah, it's been a pretty useful debugging tool to measure it. Okay, flow control. So by default, actor mailboxes are unbounded. That means I can easily write messages to an actor mailbox and run out of memory. If the actor you're sending to is very slow, you end up piling more and more messages. So any serious Akka system needs to have some flow control mechanism. There's two strategies. The easiest one to implement is called the bounded mailbox, which is exactly what it sounds like. When a mailbox is full, then what happens is that there's a configurable delay called the mailbox push timeout time. And that's how long Akka will wait to see if the queue frees up. The behavior after that timeout expires has changed. Akka used to allow you to throw an exception or to block indefinitely, or you can set push timeout time to infinity. And if you do that, then you can get kind of a basic flow control for local Akka actors. The new behavior, starting, I don't remember, I think it's Akka 2.1, is that when a mailbox is full, the messages go to a mailbox called dead letters. So there's a mailbox in every Akka system called dead letters, where messages that don't get delivered go. Your messages that go to actors that have died already also go to dead letters. The problem with this is that it doesn't work for distributed systems. So it's better to implement a real flow control mechanism that one way is, for example, that you can have the last actor in your pipeline pull upstream some work, or you can use a system like push with axe, where I keep pushing messages, but I'm going to wait to get some axe back, and if I don't get a certain number of axe, then I'm going to slow down. So there's a lot of, I won't go into those, but there's a lot of good blog posts out. If you look at the Akka team blog, there's several blog posts about how to do flow control. Those are really good, although it takes a lot more work to get those set up. Here's a great graph I like to show, that a good working flow control system means that the rate of all your actors are going to even out. So what this graph that you see is a great example of that happening, that at some point, I'm going to turn on the spigot of my actor pipeline. And you can see that there's one trace which spikes up right away and starts to drop. This is reading messages from Kafka, and which makes sense. It's going to start right away. And as the processing happens in the later stages, which are the other lines, that will start to slow down the Kafka actor because you will start to get pushback, and eventually they will all agree. Right? So that's what you want to see when your flow control works properly. How many people use VisualVM? Super useful tool. If you haven't used it, I highly encourage you to download it because it's free. An awesome way to get live production information from your JVM. Unfortunately, VisualVM is really targeted at traditional Java apps with threads. So one useful view in VisualVM is the CPU sampling, which gives you a kind of like a cheap, very rough way of estimating where time is being spent. I find this super useful when debugging the performance of my Akka apps. If you're using something like a bounded mailbox, you might see something like this, where the top item becomes this enqueue method in bounded message queue. What that means is that your apps are spending a lot of time waiting for messages to be pushed, which will tell you that the problem is with the last actor in your chain. In our case, it would be right in Cassandra. So when we see this, we know that the problem is that we're spending too much time writing to Cassandra for whatever reason. And so looking at this gives you like a pretty good quick read at what is causing problems. My dream is to have a VisualVM plugin that can visualize actor utilization across threads. So if there's any of you out there that is VisualVM developer or anything like that, you can let me know. This would be really cool to have. Okay, so you have flow control, you have metrics, you have logging. That's not a bad start. So here's the thing. In a traditional Java app or Scala app, stack traces are pretty useful because every line tells you where's the last color, and you can kind of trace through it and trace through your code and figure out where what's been happening. If you ever looked at stack traces from Akka, this is not very useful. You'll see a lot of this kind of thing, akka.dispatch or akka.jsr166y, which is the fork join pool. And the reason is because every time that Akka dispatches, then it has to use this framework. So you don't remember the stack trace, the stack no longer remembers where you've been. So how useful would it be to have like an Akka actor message trace where you can see where I've been, like the last actor to the current actor, and look at the message type, right? I think that would, for Akka apps, this would be a super useful debugging aid. Or maybe you want something like this, like a Sankey diagram with message flows. You can see on the left side the actors, which ones they flow to, how many messages roughly are sent to each one. So as hackathon, in our last hackathon project, we actually implemented something like this. And here's a simple stackable trait. Basically, what this does is that on every receive, we will try to extract out a message ID from the message that it sends. Then we send an edge to a collector. This has the sender, which is the last actor node, the current node, and the message ID. Then you can aggregate across nodes and make some pretty cool graphs. Finally, like just a few hints. You don't want to put things that can fail into the actor constructor because by default Akka will just stop. You want to like have an initializer. So if I put this all together, I now have several traits that I can mix in. I can mix in my logging, metrics, the message tracing, and I can keep the body of my actor really neat and clean, and get a lot of super useful instrumentation. Some next steps. We can possibly open source this. Let me know if you're interested or if you're interested in contributing to this effort. Thank you very much. We are hiring, so come talk to me. No.
Are you looked at TypeSafe console at all?
TypeSafe console is, yes, TypeSafe console is useful for debugging, but it costs a lot of money if you want to use it in production. It also has a performance impact, so I don't know. Yeah.
Could you tell, kind of conceptually, the stackable traits are really what you want to do, or you have to do that because you cannot inject something into Akka itself? Because, for example, this Spring framework, I can add through AOP something that will instrument a whole bunch of everything, basically with one line, and add logging and everything. So looks like what you're doing is wrapping that receive method, and naturally that's what Akka is processing.
That's an interesting thought. I'm not really familiar with Spring, so I'm afraid I can't really comment on that. I don't know if what Spring has has anything specific to Akka. I would say that.
No. It's not specific to Akka. It's just a way to define something like this. I want to apply this wrapper to all the methods in all the classes or packages that looks like this.
So I think what he's talking about is an AFP type of concern. Aspect oriented is orthogonal concern to what your actual code is doing. So inject it
I mean,
It works in Scala. I'm just interested in conceptually.
I
Do
feel
you
like
prefer the
everyone
Stackable
has a
Traits
strong
as-
felt opinion about that.
yeah, I think you're probably right.
This would
Yeah,
be a good lunch topic, seriously.
yeah, it would be a good lunch topic. Yes, yes.
A couple of comments.
Yeah, please.
The Scala community, on the whole, I would say, is deeply skeptical of AOP. And I
Yeah,
come
that's
from
probably
a strong
true.
AOP Spring background personally,
Mm.
and I've had great results from it. But it doesn't sell well on this side of the world. And also, secondly, the Akka team is incredibly protective of their internal.
Yes,
It's
yes.
not that it's a secret; it's that they don't want anybody at runtime messing around with the implementation of Akka. So it's easy to understand why they have that perspective, because it is the kernel, and you don't want too many other people's code kind of slotting in there and interfering potentially with the message flow.
Yeah, I think for us, it's just that I don't think any of us have a Spring background, so it's just that we haven't really looked at it. And we like light frameworks, so.
It's
Other
not
questions?
much about the Spring. It's just that do you really prefer injecting those aspects in the code, like coding, rather than declaratively in some other way? Like, okay, I want to push such and such things in an Akka kernel, and I want that to be applied to all actors or subset of actors.
I think we like the fact that it's declarative because we can control which actors have these. Like some actors don't need that, so we won't mix it in. So I don't know. That's just us. But there's also you can also inject the traits at when you instantiate an actor instead of in the class header. We actually like it in the class header because when you do it at the time you call new, it's easy to do it differently at different sites and get it wrong. But that's just my personal opinion.
So actually very interesting to see how I use the dependency cell on Storm. A lot of people are looking for Storm, right? So but you actually went away from Storm to an Akka cluster, right?
Yeah.
So can you just elaborate just a little bit, what's the future thinking? Are you going to use Storm for something else, like offline-based process? I mean, it's a streaming system, it's made for live. So what's the future now for Storm, Uyala versus an Akka cluster?
I think that from all of our sorry. Okay, yeah. So the question was, what's the future of Storm or Yala? Like, a lot of people are interested in Storm. I would say that we are not really a Storm shop anymore. Like our painful experience with it in production tells us that, we don't really want to deal with systems that we have trouble troubleshooting at 2 a.m. That's really how we think about it. We like simple, we like thin, we like transparent.
I guess I would ask, just following up with that, are there any features that Storm provided that you miss now that you've abandoned it?
I would say the biggest thing is that Storm has built-in automatic playback of events. I think that for us, we need to implement systems like that, but at a larger level anyway for correctness. So we haven't really missed that. But yeah.
Sorry, one last thing. Have you looked at Zipkin? That's Twitter's tracing framework.
We just heard about that. Yeah, that does look pretty neat. Yeah. It's so there's LinkedIn has a new framework called Zipkin that is designed to run a real-time processing on top of Kafka. Yes, so get into more questions. Oh, event sourced. Yes, that's right. We have looked at that. We probably will implement it eventually. Actually, we're not quite sure, but yes, event sourced. For those of you guys that don't know, event sourced is an Akka library it's a library on top of Akka that provides at least once or exactly once processing. It's pretty neat. Yeah, that's definitely an interesting project we want to keep our eyes on.
Well, part of mine, I don't have a question so much as a couple statements. One, I was going to point out event source, and that is integrated into Akka. So
Okay, cool. Yeah.
But the other thing I want to mention is your logging approach. You can actually achieve that with Akka's built-in logging. So we can talk later.
Okay, cool.
It's possible to do the JMX, like changing of the log levels at runtime. So.
Okay, cool. Yeah, we should talk. Cool. Any other questions?
Just a comment. I would be interested in your library.
Okay, thanks. Yeah. Second. Okay, cool. Cool.
push and carry.
Good to see. Okay. Awesome.
All right. Just one more comment about the whole AOP thing. If you want to do something AOP-like with like intensely dynamic modifications of behavior, you can always just write one super trait. You could write one trait that does all the rule lookups at runtime or whatever you have to do, right? Like you always have the ability to go deeper there. It's just a question of whether you're implicit or explicit. And
Okay, yeah, I can see
many
that.
of us in the community are moving in the direction of making everything as explicit as possible.
Yeah.
It doesn't have to be syntactically heavy. It can still just be apparent and small.
Yeah.
And there's never any surprises.
Yeah, we're not big fans of magic, but that's just us.
Yeah.
So.
So you said earlier that features in general are hard to understand for many developers and actors. When do you choose to use features, or do you always try to use actors, and do you use the Akka pattern?
So I'll just repeat the question. The question is, I said futures are hard to understand, so when do you use futures, or do you always use actors? Depending on who you listen to, I think there's one guy in TypeSafe that has a book coming out that tells me we should always use actors. But I think futures are a really good fit when you need request response. If you were to do the same thing using actors, you need to declare like anonymous actors, or you need to track the response somehow, right? Because you don't. The good thing about futures is that every time you send a request, you have a handle on the future. So it's built into the way futures work. But if you need to track responses using actors, you need a map, or you need to do something yourself. So it's a little bit, yeah, futures are a great fit for request response. We still use futures, it's just try to be more judicious. And we try to avoid futures stacked on futures, kind of like composing them too much and things like that.
I saw you using a lot of the wrap or receive.
Wrap receive, yes.
Is that like a common pattern you use, like an adapter design pattern or something to wrap things around with traits and stuff like that?
So the question was about wrap receive. It was just something that we found was needed for because the receive method is a partial function, and also to simplify the flow of the traits, that it's very clear that there's one trait that calls wrap receive, and so that flow is very clear. There is a magical way of doing it where you don't need a wrap receive. You can just have the base actor be receive. But in testing, I found that doesn't work with. So you saw in some examples I had where I can do this. I can declare a class that, well, maybe not this one, but there's some other ones where the class will extend one trait with another trait. So you can't do that if you don't have a wrap receive. That's just what I found. Or maybe there's some way to do it, but yeah. This.
There's a lot of, I've had a lot of issues with type safety using actors.
Yes.
Do you guys do anything to try to make your actors more type safe, or is that just?
That's a really good question. Yeah, I mean, there's not much we can get around the fact that actors basically are dynamic, right? They can take any objects. One thing is that, well, one thing we should do, but we don't do, is that you should always have something. Actually, I guess you should have a base for like. You should always like know when you pass a message that isn't identified. Like I think there's a base exception that comes across when you get a message. But like you can override unhandled and make it very obvious that you got a message that isn't handled. But the other thing is that I know Akka is adding in some new stuff. They're adding in typed channels. So hopefully that'll make things easier. Akka also has a typed actor interface where you define methods and the methods somehow map over to the existing thing. And I haven't looked at those, but I don't know. That's something that would add a lot of type safety to that. Maybe is a good idea. Yep.
Speaking of messages, you always use Java messages. You don't use something like proto buffer serialization to talk cross-platform.
Good question. So speaking of messages, do we use just standard classes or like protobuf? I guess we haven't done anything so high performance that we've looked into that we needed like protobuf. We use case classes just because they pattern match very well and they're a great fit for actors. I think if we needed performance, we would switch from, Akka has pluggable serializers. We would switch to using Creo instead of Java serialization. And that way we can still have the niceness of case classes without having to deal with protobuf and compiling, files.
We need to move on and get the next
Okay,
talk going.
cool. Okay, thank you very much. Yep.